Hi guys, welcome. Hi guys, welcome. Hi guys, welcome. Hi guys, welcome. Hi guys, welcome to our live video today. Welcome to our live section today. In our today's class, we'll be looking at sorts. Okay? When we talk about sorts, we are talking about irrational numbers. When we talk about sorts, we are talking about irrational numbers. What are irrational numbers? Irrational numbers are numbers that cannot be expressed in form of what? A fraction. Irrational numbers are the type of numbers that cannot be expressed in form of what? Fractions. Okay? So that, and in solve, it involves a square root. Okay? When we try to square irrational numbers. You know, when we talk about the rational numbers, okay, we are talking about numbers that are expressed in fraction in the sense of a over b. But if you talk about the irrational numbers, these are numbers that cannot be expressed in form of a over b. Okay? And those numbers, when we take their square root, we are talking about sorts. In your maths book, you can actually see something like root 2, numbers like root 2. You can see like root 5. You can see like root 3. You can see root 12. All these numbers are what we call sorts. These are numbers that cannot be expressed in form of what? Fraction. Okay? And those numbers are the numbers we call sorts. In sorts, we have various forms of sorts. Various forms at which sorts can actually occur. The first form at which sorts can be actually occurred is the basic sort. We call it the basic sorts. What are the basic sorts? A sort can be seen as a basic sort if it cannot be further be reduced. Let us know where you're watching from. Let us know where you're watching from. Okay? We call it the basic sorts because these are sorts that cannot be simplified further. Example of such sorts include like root 2, this one. We cannot further simplify it. We have root 3, root 13, root 10. All these are basic sorts. The reason why they are basic sorts is that they cannot be simplified further. The next one is the ones that are not basic sort or non-basic sorts. Okay? A sort can be seen as non-basic if we can actually simplify the sorts further. So example of non-basic sorts includes numbers like root 12. We can still simplify the sort and also reduce it to its lowest term. We also have the next one, which is root 20, and so on. Okay? Okay? So these are the various forms of sorts. Let us know where you're watching from. Thank you for saying hi. Please like the live. Okay, double tap, like the live. Hi guys, I want you guys to give me example of a basic sort. Write that in the comment section if you're following. Give me examples of a basic sort. One example of a basic sort for us to move. Remember, I told you that basic sorts are the sorts that cannot be further simplified. Okay? Why non-basic sorts are the one that we can still simplify and reduce to their lowest term. In the comment section, I want you guys to give me examples of a basic sort. Also give me example of a non-basic sort. When we talk about non-basic sorts, we are talking about sorts that can still be simplified. Any form of sorts that can still be simplified can be seen as non-basic sort. These are the ones we can still simplify. Then again, we have various rules that are guiding sorts. Various rules of sorts. we have the rules of sort. What are the rules of sort? These are the various laws that helps us simplify or solve problems in sort. For instance, when you are told to do the square root of a minus plus the square root of b, in normal sense, in normal addition, most students will tell you that this is equals to a plus b inside one square root. Please, this is wrong. The laws of sorts tells us that whenever we are adding two sorts together, if they are not of the same form of sorts, okay, you don't add. So what do you have to do? It still retain its value, the square root of a plus another square root of what? B. Okay? And we would. These are the few important rules you have to know under sorts. So sorts are very easy to and very simple to understand. So while dealing with sort, you should understand some of the rules involved in it. Okay? So you have it like this. Then the next one we look at is some of the simplifications in sorts. Some of the simplifications in sorts. Sorts, we can perform some mathematical operation in sorts, which are very, very easy, like in sorts, which are very, very easy. For instance, if you are told, we call it the simplification of sorts. How do we simplify sorts? We simplify sorts by reducing the sort to its lowest term. Okay, we have the goal to reduce the sort to its lowest term. For instance, if you have root 20, root 20 can actually be reduced to its lowest term by simplifying the what? Square root. What do we mean? Before we do that, we should have some of the square roots, some of the perfect squares we have. 1 is a perfect square and the square root is 1. 4 is a perfect square and the square root is 2. 9 is a perfect square and the square root is 3. 16 is a perfect square and the square root is 4. 25 is a perfect square which has 5. 36 is a perfect square which has 6. 49 for what? 7. So these are the few squares and perfect squares we have. So the squares and perfect square plays a very important role in simplifying sorts. Okay, it plays a very, very important role in simplifying sorts. How does it play a important role? For you to simplify any sort, if you look at the number, here you think of two numbers that multiplies to get the exact 20. But the thing in here is that you are going to check. If you multiply them, you get 20, but you must pick the one that is a perfect square and the one that is not a perfect square. Okay? That plays a very important role. So if you look at 20, when you multiply 4 and 5, you are getting 20. But if you look at here, 4 is a perfect square, but 5 is not a perfect square. So these are the two numbers you are going to use. So if you use that, you can still write this as the product of 4 times 5. Then the next thing you do is to split the terms. Okay? So this gives you the square root of 4 times the square root of what? 5. Okay? Then when you take square root of 4 is a perfect square and it gives 2. So what do you have? You have it as what? 2 root 5. And 2 root 5 is the answer when you simplify the sort to its lowest term. If you're following, let us know where you're watching from. Let us know where you're watching from. Let us know where you're watching from. And that's the what? Answer. Let's look at the next one. Let's say we are told to do square root of 72. If you're following, let me know your answer if you're following. Can you be able to do that? Let's try the square root of what? 72. The square root of 72. The rule still remains that you are going to think of two numbers that multiplies to get the 72. But the thing there is that one of them must be a perfect square and the other will not be a perfect square. Okay? And the one that is a perfect square must be the highest perfect square that can divide the number. So if you have 72, what's the perfect square that is closer? It is what? 36. So, and when you double 36, you are going to get what? 72. And the thing there is that 2 is not a perfect square, but 36 is a perfect square. So you observe one thing, nothing have actually what? Changed. So since you have that, what do? You have to split. So this is square root of 36 times the square root of what? 2. So the next thing you do is to take the square root of the perfect square. Take the square root of the perfect square. And when you take the square root of the perfect square, which is 36, you are getting what? You are getting what? 6. Okay? And we have it as 6 root 2. And that's the what? Answer. So this is the simple way of reducing or simplifying surds to their lowest term. So simplification of surds is very easy. Please do well to like, subscribe to the channel so that you get notified whenever I drop a new video. Then the next one is, let's say we are told to simplify root 18, for instance. If you look at root 18, we can actually simplify or reduce the surd to its lowest term. But the thing there in reducing the surd to its lowest term is to check on the list of the perfect squares that we have, the one that can divide this without any remainder and must be the closest perfect square to what? The number inside the square root. So let me know in the comments, what's the perfect square that is closest to root to 18? The perfect square is what? 9. So what do? This is the same thing as the square root of 9 times 2. Okay? This is the square root of 9 times 2. So when you have the square root of 9 times 2, this will now give you, take the square root of the perfect square. The perfect square is 9, so square root of 9 is what? 3. So the answer is 3 root 2. And that's the what? Answer. Very simple. Let's look at another one. Let's say we have the square root of 50. And we are told to what? Reduce the surd to its lowest term. To reduce the surd to its lowest term, please, where are you watching from, please? Let us know where you're watching from. Please double tap, like the live, and share, please. Like the live and share. So when you have the square root of 50, and you are told to reduce the surd to its lowest term, it is very simple. This will now give you the square root of 50 can be seen as what is the closest perfect square to 50. What is the closest perfect square that can divide 50? If you are following, let's know. What's the closest perfect square that can divide 50? What is the closest perfect square that can divide 50? The closest perfect square that can divide 50 is basically 25 times 2. 25 times 2 is 50. 25 is the perfect square. Okay? So I want you to take the square root of the perfect square. Square root of 25 is what? What is the square root of 25? What is the square root of 25? The square root of 25 is 5. So you have it as 5 root 2. You have it as what? 5 root 2. So 5 root 2 is when you try to simplify the surd to its lowest term. So it is very easy to simplify surds to their lowest term. Okay, the next one we have is we are trying to simplify root 45. Root 45. We are trying to simplify root 45 and reduce it to its lowest term. To do that, this is excellent, simply easy. What you have to do to reduce a surd to its lowest end is simple. What do? You are going to think of two numbers that multiplies to get the number in the square root. What are the numbers that multiplies to get 45? But the thing there is that one of the numbers is going to be a perfect square. One of the numbers must be a perfect square. So when you multiply 9 to 5, when you multiply 9 to 5, you are getting 45, right? Good. But there is that 9 is the closest perfect square to what? 45, to be able to pair up and solve the problem. So what do you do next? It's very simple. You have to do what? Take the square root of the perfect square. So what is the square root of 9? Let me know the answer in the comments. What is the square root of 9? What is the square root of 9, guys? What is the square root of 9? The square root of 9 is 3. So the answer is 3 root 5. Okay? The answer is 3 root 5. Square root of 9 is 3. Correct. Thank you for writing 3, okay? Thank you for writing 3. So the next one we look at the square root of, we are looking at a surd, and the surd is the square root of, let's go with 80. What is this closest perfect square to 80 that can pair up to get the answer? What is the closest perfect square to 80 that can pair up to get the answer? What is the closest perfect square to 80 that can pair up to get the what? Answer. Okay? Remember, we think of two numbers that multiplies to get 80, but one of them must be a perfect square, while the other would not be a perfect square. But when they multiply, they get what? The number in the square root. So what's the number? Why are you saying 8? You cannot say 8. Why don't we try